Let us solve another numerical problem on pulley systems quickly. There are three different masses, 1, 2, 3, two hanging from one side, one hanging from the other side. So I'll write individual equations for this one, and for this one, and I will solve it to find the acceleration. And I'll tell you the shortcut to do it quickly without writing the individual equations. Let the mass, this mass is 2 kg. I write it here, 2 kg. And this mass is 4 kg. And this mass is 6 kg. You can take whatever you like. This side is heavier, 6 plus 4, 10 is greater than 2. So this side will fall down with certain acceleration because there is a net force. So this side will move up with the same acceleration. Now let me write the equations of motion, solve it, then explain you the shortcut to do it quickly by using this shortcut trick. Net acceleration. Acceleration is net pulling force by total mass. Now the weight of this one will be vertically downward, will be its mass times g. So this is equal to 2g. And this is the string, same string. So for this, the tension to this side is T1, suppose. This is the same string. So on this part of the string also, the tension will be T1. And for this mass, it will be away from it, T1, to this side. Now, then coming back to the second mass, 4 kg. Its weight will be vertically downward, m times g, that is 4 into g, 4g. And this part of the string, which is different than this, here the tension will be different, so let it be T2. So if you consider this mass, T2 will be away from it, and if you consider this mass, then the same T2 in the same string will be T2 will be downward. Now let us write the equations of motions. For the first one, since this is going up and T1 is exactly opposite to 2g, so the net force on this is vertically upward to this side. So the equation will be T1 minus 2g is the net force on this. That will be its mass into acceleration, 2 times a. Equation 1. Then if you look at it, its weight is also vertically downward, 6 times g. Now just look at this, don't look at this. Now if you look at this only, then what do you find? It is, there are two lines touching this. One line here, one line here. Means this is acted upon by two forces, 6g downward, T2 upward. And this is coming down with acceleration. So 6g must be more than T2. Then there will be net force downward. So that will be mass times acceleration. So for this mass, and the equation will be 6g minus T2 will be 6g minus T2 will be its mass into acceleration, 6a. That is equation 2. Now if you look at the middle one, if you just look at this, don't look at this. One line here, one line here, one line here. Means three different lines are touching. Means there are three different forces acting on it. 4g downward, T2 downward. So 4g plus T2, and that is being opposed by T1. So minus T1 will be its mass, 4 times the acceleration. Now if you add these three equations, you will definitely get the value of acceleration. Plus T1 minus T1 cancels, minus T2 plus T2 cancels. On the left hand side, we have 4g plus 6g, 10g minus 2g, that is equal to 8g is equal to 6 plus 4, 10 plus 2, 12 times a. So your acceleration is equal to 8g over 12. If I take g as 10, 8 into 10 over 12. So if you cancel this with 4, I get 2, cancel this with 4, I get 3. So 20 over 3 is your acceleration. And what is that? Meter per second square. 20 over 3 meter per second square is the acceleration. To do it quickly, let us imagine these two masses. I keep it like this, horizontal, and this mass I also keep it horizontal. Means I make this whole system horizontal like this. And this 6G, which is a pulling force, 6G, and the pulling force for this is 4G, also to the same side, 4G, and the pulling force for this is 2G. If you make it horizontal, this 2G will be to this side. I am not considering the tension. Only the pulling force, right? So 4G and 6G, they are in the same direction, and 2G is opposite to that. So the net pulling force is 6 plus 4, 6G plus 4G minus 2G, 6G plus 4G, 10G minus 2G, that is equal to 8G over total mass. And total mass is 2 plus 4, 6 plus 6, that is 12. So, using this expression for such system, 8 into 10 over 12 cancels with 4, you get 2, cancels with 4, you get 3. You also get the same thing, 20 by 3 meter per second square, as we derived it here from the equations. Now, for tension, there is no such shortcut like this, but you have to put the value of acceleration in different equations to find the tension. For example, if you come here, if you come to equation 1, your T1 will be 2G goes to the other side, 2 for G I put 10 minus, plus 2 times A, 2 times A is equal to your 20 by 3. So this comes out to be 20 plus 40 over 3, that is equal to 60 plus 40, 100 over 3 Newton is your T1. Now, means the tension in this part of the string. Then for T2, you can find it here also. You can find it here. Now you take T to the right hand side, this becomes positive, and this 6A comes to this side, so it becomes 6G minus 6A. So that is, if you take 6 common, you are left with G minus A. If you take G as 10, 10 minus A we just calculated as 20 by 3. So this comes out to be 30 minus 20, 10 over 3, 6 into 10 over 3, that is equal to 60 by 3 Newton. So your T2 is also found out. In this part of the string tension, and this part of the string tension is also found out. But acceleration you can find out quickly by using this expression, net pulling force by total mass, right? So I hope it is clear to you.